Okay, so now let's talk about world position. We've talked a little bit already before when it comes to like the landscape and acquiring the slope information. But for this, we're going to talk about how to apply blending to a texture with world position instead of the normal UV coordinate system. So we're going to talk about it in three separate ways. One is with a single directional plane blend. The second will be triplanar blending, and then the third will be like a terrain, like a height lerp overlay with the directions. So the first thing I think I've already talked a little bit about is world space and object space. So currently, right now, this cube is set to object space. So it rotates and orients to the object itself. No matter where you rotate it, the orientation will always stay the same to the object. If I go up here and I select from this little cube, I can change it to world space. So when I do this, it keeps the coordinates the same because the world has its own coordinate grid system. And you can't really change the world's rotation. That's always going to be the same. It's an absolute function. So that's how we are handling the world position. So let me go ahead and let me make a new material. And this one will be called prop WP underscore MMAT. And this is going to be our base one for world position. So first, what we're going to do is let me start bringing in some parameters. Let's do some texture sample parameter 2D. There we go. So we're going to do a base material with this guy. So here's going to be our albedo. Here's going to be our normal. And then here is going to be our ORM. And then let me throw in those base textures. Base underscore albedo, base underscore normal, and then base underscore ORM. Let's hit save. Let's plug these guys in. O, R, and our M. So now the next thing is that this is just a normal material. By default, it's going to use UVs based off of whatever it's going to be applied to in objects with UVs. So what we need next is instead of calling for a texture coordinate, where that's how it defines our tiling and stuff, we start to call a world position. And when you start typing that in, it's not going to automatically pop up because it's going to go down to wind. If you start scrolling up, you'll see right here under coordinates, it says world position. And I've said this before, when you see these types of red tabbed nodes, it's they're using scene and level information. Now, you don't have to do any of these kind of changes for your world position and stuff. So, by default, it does absolute world position based, including these shader offsets. You can even take off shader offsets, or you can set up world position based off of uh, the orientation to the camera, almost like screen space world position. But we're not doing that. We're using actual world position. And so, if I plug this guy in, it's going to look really weird when I start applying a texture to it because the tiling is going to be off very weirdly. So, like how we did for creating our tiling for landscapes, we're going to need to do a divide because it's going to be the complete opposite of how you handle textures. And then you're going to do let's do a parameter. Let's convert the parameter. Instead of doing UV tiling, we're going to just do world scale. Since this guy is going to be, he's going to be the one that's handling our everything basically. And since these are going to be in an interesting kind of position to it, we have to kind of do negative space since it's all inverted and not just handling single things inverted. So let's plug that guy in. And then if you want to try and do that, You can do that, but then you have a problem because it's taking this guy, which is float information of three things and trying to apply it to UVs will not work. So what you need to do is you need to apply a component mask. So you can go in here, hit that, and then you don't have to change anything else because by default it already chooses R and G. So the first two values for this guy would be the U and the V instead of just having to switch between any of these other colors. R and G default to U and V. So if you plug this guy in, it works. Same thing for this guy and same thing for this guy. Now let's hit save. And now let me create an instance. And this one's just going to be called box WP IMAT. Because we're just going to apply this to the box first. So let's drag and drop him. Let's go inside of our instance. And let me turn on. Oh, I accidentally did not set the normal mouse name. But let me try and find that metal painted texture. And let me add that last normal map and boom. And let's also set our scale. So you can actually go in here and adjust our scale if you want to. So setting it to 0 tiles it so much. And then if you tile it to like 100, it does the same thing too. So you can set them both negatively or positively. It just sets how the tiling is going to be reversed or not. So it's tiled like 100 times. So let's do 500. So we get close up to almost like a 1 maybe. And cool thing is that if you actually go and move this guy right now, you'll see that the textures don't actually move with the object. The object will move, but the textures stay the same because their coordinates aren't attached to the box, but to the world itself. It's kind of like if you've ever seen the cartoon like Chowder or something. In Chowder, they use parallax materials for the cloth for the characters so that when the characters are moving, the fabric pattern itself stays static, but the characters are moving along it like this. But then you also notice now that our UVs are a little off because it's setting this guy to be like one single position versus like other positions. Let me go back here. Let's see if I can change some value to it. So right now we have our R and our G. So let's try and set our G and our B. So now it's going up and down. So it's using the red channel to handle our, let's see, actually, when I start moving it. So when I move this guy, he handles up. So yeah, so this is the up and the down. But then you're still going to have this problem here. So if I even start rotating, it still has an issue. And all this is it's projecting. So that's why sometimes when it's doing this and stretching, it's trying to figure out where the top and the bottom or whatever the direction starts and whatever the direction ends. And that's why it's stretching across because it's projecting this information and not handling through textures. So if I go back in again, and maybe instead of G and B, let's do R and B. You see now it's on this direction instead. So I do this, let me rotate him back to normal, normal. See that there he is, and let me start moving him now. Let me lock our values in. There we go. So you can see that he's there. set like that. And if I go back in and do the same thing again where I set that, and now he's set like this. And then same thing if I go back here and I just do the R and the G. So it's masking out your value, but also setting it as like UV coordinates. So it's projecting it along an X and a Y, or a Z and a Y, or an X and a Z. So that's just a like single plane projection. Next thing is that we want to try and set it up so that maybe we want to have it where it can project multiple times. So we'll go here back into our materials. And where is our prop world plane? So I'm going to change that. And we're going to change the W to a T for triplane. So triplane projections is taking all three dimensions and it's actually going to basically try and blend them all together into a specific type of direction and try and approximate the values properly to it. It's if you ever used Substance Designer or no, not Substance Designer, Substance Painter before, that's how it works basically. So in our case, what we need to do is so let's take our absolute world position and then let's move our scale and our position here. And then what we're going to do next is we're going to set multiple values for this guy, for this one here, this mask orientation, because we need to have three separate versions of it. So if I go here and here, so let's set our G and our B, and then let's set our R and our B. So now we have our three. What we're going to do next is I'm going to take this this texture sample and I'm going to convert it to a. Let's see if I can convert it here. Just current texture. No, so I can't do it here. So let me do a texture object parameter. This one will be our albedo because what we're going to do next is I'm going to delete this parameter 2D and I'm going to call in a normal texture parameter. Texture sample. There we go. And then what I'm going to do next is let me apply our base albedo to him. And I'm going to make 3 copies of him as well. Because like I said, what's going to happen is you're going to derive all of your information based off of these values. So we've masked out each direction of the world projections. And then we're going to plug them into these UV spaces. And then we're going to apply our texture information from this texture object parameter into these texture samples. And then now we got to figure out how we're going to blend this guy. So what we're going to do is we're going to need to use information that's also world space or world position based. And we need to try and figure out what we're going to do and how we're going to try and define some things to it. So what we need is kind of like what we did with the slope one. We're going to use some vertex normal world space information because we need to kind of define on the normals or the directions of the 3D object, how is it going to try and mask properly the values between these guys? So we're going to take this information, we're going to apply this node, which is ABS or it's like absolution. So it takes our information and it approximates it into a single value instead of 3 different values. And then what we're going to do is we're going to, no, not panner, use a power on it, and we're going to strengthen it. And by default, it's strengthened with the constant power of 2, because that's all we really need for it. We just need that kind of base kind of strength to it. And then next, what we need is we need to break out this value and set it to 2 separate values. So we're going to take this information that we've already kind of approximatized, and then let me take a component mask like one of these guys. we'll do 2 because we're going to break them out separately. And then we're going to set this guy to G because for our UV sets values. And each one of these is going to apply a direction of this vertex normal and use it as one single information. And this is how it's going to handle the lerping between each one of these particular values. So let me grab some 2 lerps. Let's apply them to our alphas. Then we're going to apply our first direction and our second direction. And then we're going to apply this and we're going to apply our third direction to this guy. Then we're going to plug him into our albedo. And then all you need to do next is do the exact same thing. So copy all this, or at least, copy this part. So copy and then paste and then paste. And then do the same thing for instead of albedo, we'll do normal. And let me set our value to normal and then change our base to normal. And then this one will be our ORM. And then this will be our linear color. And then let's do our base ORM as well. Nope, not the normal map. Base ORM. And then let's plug in this information to everything. Oh, let me delete these parameters. Oh, it might, yeah, defaulted it by accident. Base color albedo. So now we don't have that problem. So let's apply the world information to all these guys. Let's apply the alphas to the lerps. Plug that guy into the normal map. And then we're going to plug all these guys in as well. And then let's plug in these last lerps, and then we'll test it out. Oh wait, forgot. I gotta set this guy up and do our breakout component 3 because we have a single value for him. So next thing we'll do is we'll grab our red channel, do our ambient occlusion. I do a green channel for our roughness, and then we'll do our blue channel for our metallic. So let it apply and save. And then what we'll do now is let me create a new instance. And this one will be boulder underscore TP underscore IMAT. Let's grab him. Oh, I think I didn't define the parameter for him for the ORM. Okay. Now let's hit OK. There we go. Let's go apply let's grab our textures. Actually, no, let's go into our sample textures. I'm going to grab that, this rock basalt. I like this one a lot. Grab that, and we'll just grab our normal map. And then just by default, I've already thrown in the ORM to it. So now let's grab, let's go to him and just drag him on there. And as you can see, we now have a normal map that is applied to all single directions of this guy. And it looks pretty seamless, actually. You can rotate it too. And you can see that it kind of moves with the texture as well. But he is fully textured and it's blending with to every single direction for him. And of course, you can go a little bit further, maybe apply a broad normal as well. Like find the normal map for this boulder's texture, and then do that material normal blend with the normal information of the triplanar, so that you can get these defined cracks. And you can do also the same thing if you do like a simple bake for other things as well. And then finally, let's go over one last thing. So we're gonna handle a very simple. It's a very simple blend, but it's very useful. So let's go back in here to our master material. Where is he popping up at? Oh, I think it's like hidden somewhere, maybe. You, so you're here, folder mat, up, EP. There we go. Got him. So now we need a very simple node. And we've already used this node beforehand when it came to the height information in the landscape. So we're just going to go in here. We're going to type in world aligned blend. We're going to do it a little bit differently. So this guy, let me grab actually something simple in here. Where is, since this is a boulder, boulders are going to have something very particular set in a very directional kind of way. Moss. So let's go in here. I need two values. So let me grab two parameters, convert them. This first one will be called our blend sharpness. Set to like about like 3 maybe. And then this one will be called our blend bias. And we'll set him to about like a 3 as well. So now let's plug that into blend bias. Let's plug that into our blend sharpness. And then what we'll do is we're going to grab one more lerp, and we're going to apply the alpha to him. And then we're going to apply the explicit normal to him, because it's going to use normal information to help with lerping things. So we're going to plug the moss alpha here. We're going to apply the lerp of all those normals here, the normal map. And then we'll do the same thing to our moss. Plug him in. Plug him into the base color. And then let's minus that. And now you can see his strength is maybe off by a little bit. So let's go in to our master material. And let's grab, let's adjust the instance on it. There we go. Now we're starting to do it. Now let me change the sharpness on him. Let's change our bias just a little bit more. I only want like certain parts to show up on it. So now we actually have moss set up to blend properly with the right direction for it. And of course, by default, it does a top-down value to it. Um, if you need to change anything, you just go right here into the world line blend, and then you would apply in the world vector, and then that it's kind of like what we were doing here. We were defining our values, so we were using absolute world position, and then you component out like what direction you want to set for these guys. Is going to require a couple little things here and there to kind of figure out and fine tune. But then that's how you can adjust your direction for the moss and stuff. But by default, it sets it properly to what we need. This would be great for like if you want to have more weathered rock on the top surface, or moss, or um, dirt, dust, even snow as well. So you can even start to rotate this guy, and because of the setup for the material, The moss stays exactly the same because it's set to the UVs, but the rock and everything and the position of the moss is actually set in a different kind of way. So if I want to, I can actually move it. And there you have it. And that's essentially the basics of world position. There's a ton of other things you can do, but this at least will start you on the path to try and figure out that not everything needs UV textures. You can just, I this is most likely this is mostly disregarding the UVs for this mesh and just applying it in a direction. And then since I have the triplanar set up, it's applying it to every single direction on there. And that's pretty much it.